our yellow note packet. We're on this one. I labeled this one because I knew this is where we were going to section it off. So the first part of the section, I focused on just the ratios. This part, we're actually going to focus on using ratios to help us find missing sides and angles. And hopefully this seems a little familiar because we did do it some last year. So if it seems familiar, that's why. If it doesn't, that's why we're reviewing. So typically we have to use SOHCAHTOA for these. We have worked a little bit with finding a missing side length. If I give you two sides, it's pretty easy to find the third side using the Pythagorean theorem. Now we're going to work with finding a missing side, but instead of knowing two sides, so you can find the third using the Pythagorean theorem, you're going to know a side and an angle. So if you know a side and an angle, we can use SOHCAHTOA to help us out. Because like I said, with SOHCAHTOA, there's four main parts. You have the trig function that you're using, you have an angle, and you have two sides, okay? So what's going to happen is you're just going to be missing one of those sides, and since you know all the other parts for that ratio, we can use that to find the side that we need, okay? So up to this point, we really haven't been labeling angles. We've been keeping them as our theta. But like I said, if you look at my triangle now, I actually know one of the angles. So this is the angle that we're referencing. Now I know we know enough information we can find the third angle if we want, but if I'm just asking you to find the missing side length, if you notice where my x is, that's the only thing I'm concerned about finding for this triangle, okay? So I have to look at the side that I know, to discover which side that is, and then what side I'm trying to find. That'll help dictate which one of the trig functions I use, and then I can find that missing side that I have there. For this, we will go back and focus mostly on sine, cosine, and tangent because those are the ones that are programmed into our calculator. Could we use the other three? Sure, but those aren't programmed nicely into the calculator, so we're going to focus on using the main three, sine, cosine, and tangent, to help us find the side length. Okay, so what side is 7? The hypotenuse, yep. That automatically reads out tangent. We can't use that yet. Okay, so it's going to be either sine or cosine. So then, where the x is labeled, what am I looking for? The adjacent or opposite side? Adjacent, because it's next to the angle. So which trig function am I going to use? Cosine. Yep. Because if I'm looking for adjacent and I have hypotenuse, I can use cosine because those two things are related using cosine. So how do I set it up? So instead of putting an angle, theta next to your trig, now we actually know the angle, so that's where 35 is going to go. And then it equals adjacent, which we don't know, so we're going to leave that as x over hypotenuse, which is 7. And then we just need to solve for x. So cosine of 35, you can type that at any time in your calculator. Usually I leave it at the end because for the most part you should be able to type all this all in at once as long as you have it all solved correctly. So as soon as you type cosine of 35, it's going to give you a crazy little decimal. So I usually leave that until the very end. So I'm going to focus on getting the x by itself over here, which right now it's being divided by 7. So how do I get rid of the 7? Times it over here. So then in my calculator, I can just do 7 times cosine of 35, and that'll tell me what x is. Okay. One thing I will mention is we've been using these calculators in calculus right now. We have to switch the mode. So if you're using one of my calculators, you need to make sure it's in degrees. So the way you check that is next to the second key, there's a button that has the letters DRG on it. If you click that, it needs to be underlined under degree, not radian. We'll talk about radians eventually. So I'm going to do 7 times the cosine of 35. That equals 5.734 and so on. So usually I just have you round to the nearest 10. So we're going to do 5.7. And that's that side.
Do you want to solve for all side lengths? Just that?
Just that one. I will eventually have you find all sides, but sometimes I just asked you to find one side or one angle. Okay. Questions on the first one? Alright, so let's do another one. I'm very bad. Usually when I draw triangles, I draw a nice, like, right triangle like that. So sometimes I try to switch it up because they don't always work that way. When I hand draw it, most of my triangles end up looking like that. It doesn't matter if you're hand drawing it. But I try to give you some varieties. That way we make sure we're good to go with labeling what triangle based on the angle. So this triangle, I made it too small, so I couldn't quite put the angle there. Every once in a while you'll see it like this. So this 21 degrees is based off of this angle. So I know this angle 21. I know this side, and I'm looking for this one. So what is 9 compared to my angle? Opposite. And then what am I looking for?
Adjacent.
Okay, so if I have the opposite and I'm looking for the adjacent, which trig function can I use to help me out? Tangent. Yep. So I have tangent of 21. Again, now we're going to actually know some angles, so it's not just going to be an automatic theta there. So it's going to be the angle. A equals opposite, which I know, over the adjacent, which I don't. It's really messed up. This one's slightly different because x is now in the denominator of our ratio. Essentially just adds one extra step. Okay? Now up here I can just multiply the 7 over here just fine. I cannot just multiply the 9 because the 9's not being divided. What's being divided? X. So what should I multiply over here? The x. Yep. So your next step should always be to multiply, but you can't just multiply either one of these numbers. It has to be multiplied by whatever is on the bottom. Up here is the 7, so that's really all we had to do. Over here is the x. And again, like I said, we can always type in tangent 21 in your calculator at any point. Whenever you do a trig of a number, it's always going to be a really tiny, crazy decimal. So usually I leave it in the trig format for as long as I can, so that way I'm not working with that tiny decimal. And also you're not rounding in the middle, we're just rounding one time at the end. So now I have x times the tangent of 21 equals 9. And then how do I solve for x? We're going to have to move the tangent, but we're not going to subtract it though, since it's being multiplied.
Oh.
Yeah. I knew you. So like I said, if you do this right, you should be able to type it all in at once. So instead of saying 7 times cosine like we did for the first example, in my calculator I'm just going to type 9 divided by tangent of 21, and that'll give me that side length. So it's 23.4. Depending on the triangle, sometimes we might be working with the situations. You might have a label, so like if I put meters or feet, just make sure you label the side length accordingly. If we're talking about angles, do try to make sure you put the little degree symbol if we're finding an angle. But like I said, sometimes you'll just be asked to find one side. Do we have enough information to find everything? Sure. Okay. Do I always want you to find everything? No. So sometimes I will. You just have to look and see what I'm asking for. So usually if you see just one X labeled on the triangle, I'm just asking you to find that one side. Questions about those first two? Now sometimes you're given a little situation behind your triangle, but ultimately you're going to have to draw out the triangle for the situation. We know it's going to be a right triangle. We just have to make sure we label the parts accordingly. So we're looking at a competitor in a cross-country meet, must run an incline part of the course. The hill is at a 48-degree angle from for a horizontal distance of 75 feet, sorry. Determine the distance from the start of the hill to the top of the hill. Okay, so the first thing I'm going to do is draw a triangle. If you want to try to draw it like all nice, where you draw the little dude running up the hill, you draw the hill, that's fine. Usually I just draw a triangle. Is that okay?
Yeah.
That's a very steep hill. If I'm thinking that it's still, that would not be very fun to run up. But what I drew, so that's what we're gonna go with. Alright. So we have two bits of information. We have a 48-degree angle and we have a 75 feet. So we just need to make sure we label that. Typically when you're talking about an angle with a situation, usually it's the angle measured from the ground up. So whenever you see that 48-degree angle, that's talking about that ground up. So we're talking about this incline part of the course. So I'm going to put my 48 degrees here. And like I said, typically that's the angle that we know. Okay, it's very hard to measure this angle. So most of the time, if you're given an angle, it's from the ground up. Okay. So then we have to look for a horizontal distance of 75 feet. Where would a horizontal distance be? Right. Yep. So usually when you're labeling a triangle, there's 3 different ways to do it. Horizontal distance, that'll be this side. So that's where I'm going to put my 75 feet. Okay. If it's talking about a vertical distance, it'll be this side of the triangle. And then some sort of incline or diagonal. A lot of times I talk about a ramp. So if you're building a ramp, that's usually the hypotenuse. So usually if it's a horizontal distance, it's this side. Vertical distance, this side. Some sort of incline or diagonal distance would be your hypotenuse. So we're determining the distance from the start of the hill to the top of the hill. So which side are we trying to find?
Well, you drew yours different than mine. Yeah, it's still the hypotenuse.
If it helps draw. So like I said, usually if you're trying to, if you're look at the situation, so if it says from the start to the top, usually your pen will draw the side that you're trying to find. So we're trying to find the hypotenuse. So which trig function can we use? Because we're looking for the hypotenuse. What side do we have? Adjacent. So which trig function can we use? Cosine. Cosine, yep. So cosine over angle equals adjacent over hypotenuse. We also use sine sometimes too. I don't know. I just make it up. Alright, so again, x is on the bottom. We're going to multiply the x over here. So we have x times cosine of 48 equals 75. And how do we finish solving for x? Divide the cosine. So we'll do 75 divided by cosine of 48. So it's 112.085, so I'm going to do 112.1. This one we're actually talking about a situation, so I'm going to look for a label. What would our label be? 8. Yep. Perfect. Alright. Questions so far? Alright, so that's how you can find a side, given an angle and an additional side. Now we're going to talk about how we can find an angle. Alright, you already have all this, so I'm just going to leave it up. So here's the big thing that you have to remember. In trig, we have reciprocal functions, and we also have inverse functions. They are not the same thing. So when we're talking about the reciprocals, that's when we use the secant, cosecant, and cotangent. When we're talking about inverse, that's where we use sine -1, cosine -1, tangent -1. Okay? So we're going to use these because they're also programmed into your calculator. Usually, it's a second feature of whatever trig function you're talking about. So if we want sine inverse, you can do second sine, cosine inverse, second cosine, tangent, second tangent. Okay? Like I said, these are not the same as secant, cosecant, and cotangent. So trig has a lot of different functions. So inverse reciprocal with trig is not the same thing. So what we can do to find an angle, so I have these set up to find angles. So usually our angle is labeled with a theta, so that's why I have a theta here. We use sine inverse, and you can notice the ratio remains the same. So it's still SOHCAHTOA. So if you know the opposite and hypotenuse side, you can just put that inside the sine inverse. That'll get you that angle. If you know the adjacent and hypotenuse and you're looking for that angle, put it inside the cosine inverse. That'll give you the correct angle. If you know the opposite and adjacent side, you put it into tangent inverse, and so that'll give you the correct angle. So it's still SOHCAHTOA. That's a nice thing that SOHCAHTOA doesn't change when you're finding an angle versus a side. What changes is the type of function you use. So instead of just using regular sine, cosine, and tangent, you now use its inverse to help you find an angle. Does that make sense? So we're going to focus on this first example. So again, the theta will be labeled for which angle we want you to find. Okay? Like I said, we have enough information. We can solve for any one of the sides or angles that we're missing. And like I said, eventually you'll have a triangle where you do that. But sometimes I just want you to find either one angle or one side. So based off of the angle that I'm trying to find, I need to have two sides in order for this to work. So what two sides do I know?
Opposite hypotenuse.
Opposite and hypotenuse, yep.
You have a speech impediment now.
That's not a speech impediment.
I meant to say hypotenuse.
It's okay. They're all good. I know what you meant. Alright. So if we know the opposite and hypotenuse side, we're trying to find this angle, which trig function can we use to help us? Sine, and specifically sine inverse. Okay? So the big thing you have to remember is that when you're setting up these ratios, the opposite hypotenuse ratio goes inside the sine inverse. So our angle, our theta, is going to equal sine inverse of 12 over 15.7. So in our calculator, we need to do second sine and then do 12 divided by 15.7. 49.84. Okay, typically with angles, I want you to just round to the nearest whole degree. Okay, so since it's 49.84, I'm going to round that to 50 degrees. And there's my make sense? So let's do the next one. So we're finding that angle. What two sides do I know based off of the angle I'm trying to find? Yep, this is the adjacent side. And this is my hypotenuse side. So which trig function can I use to help us find this angle? Cosine, and specifically cosine inverse. So your cosine inverse of 14 over 16. We have 28.95, so I'm going to round that to 29 degrees. Okay, questions about finding an angle? Okay, so now what we've been leading up to. Well, technically these are related. If you're ever asked to solve a right triangle, okay, so not find a missing side, not find a missing angle, you're asked to solve a right triangle, that means I'm asking you to find all the missing sides and angles. So like I said, what have we been leading up to? So there's sometimes I'll ask you to just find a side, sometimes you just have to find an angle, sometimes you have to find all missing pieces. Okay, so there's three tools in our toolbox that we can use to find that. The big one is you'll have to use SOHCAHTOA at least once throughout the process. The other thing you can use is the Pythagorean theorem, because if you know two sides, you can find the third side using the Pythagorean theorem. The other thing that we haven't mentioned yet, but hopefully you guys remember, is what do all the angles add up to in a triangle? 180 degrees. So we can use the sum of the interior angles equaling 180 to find another angle. Okay? So let's look at a triangle. So you will need 3 bits of information. angle is 90. And then you'll either need to be given an additional angle and a side or 2 sides. So you always need 3 pieces in order to do this. If you just have 2, it's not going to work. Okay? So you need at least 1 side and then either an additional side or angle along with this 90-degree angle. So you always know this one angle, and so then you'll either need another angle on the side, or if you just have the right angle, you can have it 2 sides, because then you can find an angle using simple tone. Okay? So usually the way we label triangles, capital letters indicate angles, lowercase letters indicate sides, and typically there's a relation. So usually if it's a capital letter A, the side across from it is labeled with the lowercase of that. Okay? And then same thing, capital B angle, a side across from that is lowercase c. Okay? Capital C angle, lowercase c across from it. That one we already know, so it's not a little c. And it doesn't have to be A, B, or C, but that's typically how we label triangles. So usually the side across from the angle is related. Okay? That's what they're relating with the variables. Okay? So we know the 90-degree angle. We know that 41.4 degrees is this angle A. And we know 28. What side's the 28? The hypotenuse. So we're missing angle B, side A, and side B. Okay, because we also know angle C, because angle C is the right angle, which is 90 degrees. So we need side B, side A, and angle B are the 3 things that we need to find. What is the easiest to find first? The angle. Because if we already know that these 2 angles, this one has to be something so that it adds up to 180 degrees. So you just do 180 minus 90 minus 41.4. So you get 48.9. And that is angle B. Usually I have you round to the nearest whole number, but since that's one that's already rounded to the 10th, I typed something wrong. That definitely should be a 6. Yeah. Yeah. That's definitely 48.6. I use my brain instead of calculating. Okay. So that's our angle. I didn't write any work for that. Was everyone good with where that came from?
Good.
Okay. So now it's really your choice what you want to do to find side A or side B first. So it doesn't matter which one you find first. So you want to find side A or side B first. B.
Pick one.
Okay. So we're going to find side B. So I'm just going to use this angle that's already labeled in my triangle. So based off of this angle, what is B? Adjacent. Okay. So using this 41.4, the hypotenuse, how can we find this adjacent side? Cosine. Yep. Because if we know hypotenuse and we're looking for adjacent, cosine is the way we want to go. So I'm going to use cosine of 41.4 equals adjacent over hypotenuse. Well, that's nice because the number's on the bottom. Usually when the letter's on the bottom, it takes an extra step. Okay. Now, I typically use the angle that's already given. Could you use that other angle? Sure. Okay. But the big thing is, if you label your angle based off of the 41.4, don't then switch in the middle to use the other angle, because that switches what adjacent and opposite are. So that's why I just use the one that's already labeled. So to solve for B, what do we need to do? Yeah, just take the 28 over here times the cosine. So you have 28 cosine of 41.4. So you get 21.003. That one's close enough that I'm just going to round that to 21. Okay. So usually I write like a tenth in there, but since it was 21.003, I just round that to 21. So usually whole or tenth is what I'm looking for, and all of the roundings, because that's really all we need for sides and angles. So now we know that this is 21. Now you get a choice. Okay? We just need to find the other side. There's actually two ways to do it. What's one way we could find it?
A squared plus b squared equals c squared.
So now that I know this number and this number, I can find A by using the Pythagorean theorem. A squared plus b squared equals c squared. Okay? What's another way I could actually find it?
Using the angle.
We do sine.
We use SOHCAHTOA again. We just have to use sine. Doesn't matter which way you do it. No. Okay? Either one is fine. I'm going to switch to use Pythagorean theorems. That way I do each method here. But could you use sine to find this side? Sure. Okay? It doesn't matter which way you do it. You should get similar answers. So I'm going to do a squared plus 21 squared equals 28 squared. And then solve for a. So got a squared plus 441 equals 28 squared. 74, 441, a squared equals 333. Okay, now here's where everything gets a little tricky. Up to this point, if it didn't square root evenly, we left it as a square root. Okay, this is where you have to pay attention. If I'm looking for exact answers, then leave it as a square root. If I'm looking for you to round, solve it out. Okay, this is where it gets a little tricky because depending on what we're doing, I want you to do different things. Okay, so this one doesn't solve out evenly, but since we're talking about a triangle, not just the ratios, I want you to solve it out. So A is going to equal 18.5. Okay, so that's where it gets a little bit tricky for you because depending on the direction, will depend on what you do with that square root. So if you see the word exact in the directions, then leave it as a square root. If you see the word round in the directions, then solve it out. Okay, does that make sense? Okay. Any questions? Only about 6 minutes left. Okay, so I'm gonna stop there. I may go ahead and go through the second example tomorrow, but that's a good place to stop for now. We only have 6 minutes. So you're gonna get a worksheet. Okay. On the worksheet, there's different sections of triangles, and I'm gonna cut this down so you don't have to do all 24 of these. But the first section, you're just finding one angle. The second section, you're finding one side, and this back section, you're finding all of the missing sides. Okay.
Could I like